Hi and welcome. I was recently asked to produce a video on working with C# using Visual Studio Code as the code editor. So I have produced this tutorial, which is a step-by-step guide to coding a basic C# application using Visual Studio Code. Please note that videos for the C# Advanced course will continue to be released on this channel soon. But during the creation of the C# Advanced course, I may occasionally release videos on other topics that may be of interest to this channel's viewers. Please consider subscribing for more content on programming-related topics and much more. And please ring the bell so that you'll be notified of future releases from this channel. So let's get started. Firstly, what is Visual Studio Code? Visual Studio Code is a streamlined code editor with support for development operations like debugging, task running, and version control. It aims to provide just the tools a developer needs for a quick code build, debug cycle, and leaves more complex workflows to fuller-featured IDEs, such as Visual Studio IDE. So please note that Visual Studio Code is not a .NET IDE. IDE stands for Integrated Development Environment. It is an editor that can be used for creating code in many different languages. Accordingly, Microsoft do not pre-package it with .NET tooling. You need to configure it yourself with a few simple extensions. Visual Studio Code is a free, open-source, cross-platform, lightweight code editor. You can create your applications on Windows, Linux, or Mac platforms using Visual Studio Code. In this tutorial, we'll learn to create a basic C# application using Visual Studio Code as our code editor. We'll learn how to code, build, and debug our C# application through Visual Studio Code. I'm going to create the sample application on my Windows PC for this tutorial. After we have developed and run our basic C# application, we'll look at how we can install NuGet packages through Visual Studio Code, and also look briefly at how we can build a basic MVC web application written in C# and using Visual Studio Code. This is a beginner's guide, so let's start from the beginning. Firstly, in order to create a C# application using Visual Studio Code, we must ensure that we have the .NET Core SDK installed as well as Visual Studio Code installed on our development computers. So if we don't have the latest version of the .NET Core SDK, or don't have the .NET Core SDK installed at all, let's install the .NET Core SDK. It is very easy to find the location from where we are able to download the .NET Core SDK. We can simply type .NET Core SDK into Google and perform a search. Then in the search results, we can simply click on the link marked .NET Core SDK. In this webpage, we are given a choice to install the .NET Core SDK for a 64-bit Windows platform or a 32-bit Windows platform. The 32-bit Windows platform is denoted by the label x86. So I have a 64-bit Windows platform. So I'm going to click on the link denoting the 64-bit installation of the .NET Core SDK. An elongated window appears at the bottom of the screen, and let's choose to run the installation. So let's click the Run button. And we are now presented with a simple wizard. So let's follow the instructions and install the .NET Core SDK. Now that the installation of the .NET Core SDK is completed, if we go back to the command prompt and type .NET-info, we can see that version 3.1 of the .NET Core SDK has been installed successfully. And now let's install Visual Studio Code. So let's type Visual Studio Code into Google and run a search query. And in the search results, let's click the link marked Download Visual Studio Code. You are, of course, also able to navigate directly to this location through the appropriate link that I have provided below in the description. On this webpage, we have a choice to install either the 32-bit version or 64-bit version of the software. As already mentioned, I have a 64-bit Windows platform, so I must select the 64-bit version. And let's click the Run button. Let's accept the agreement. And on this dialog box, I recommend clicking the checkbox labeled Create Desktop icon. This will mean once Visual Studio Code is installed, the software will be immediately accessible from your desktop. And then it's just a case of following the steps presented by the installation wizard. I have already installed the latest version of Visual Studio Code, so I'm going to cancel the installation. But if you don't have a version of Visual Studio Code installed, please follow the installation steps until you have installed Visual Studio Code. Now that Visual Studio Code has been installed, let's right-click the Visual Studio Code shortcut icon on our desktops. Let's click Run as Administrator on the context menu item. Please note that we are able to keep our version of Visual Studio Code up to date by clicking the Help menu item and then the Check for Updates submenu item. This action will install any of the latest updates that may be available for Visual Studio Code at a given time. As you can see, Visual Studio Code is up to date on my computer. The features that Visual Studio Code includes out of the box are just the start. Visual Studio Code extensions let you add languages, debuggers, and tools to your installation to support your development workflow. We are able to download and install extensions from the Visual Studio Code Marketplace, which we are able to access from within Visual Studio Code. The first extension that will aid us in our development of C# applications is the OmniSharp extension. OmniSharp is a set of tooling, editor integrations, and libraries that together create an ecosystem that allows us to have a great programming experience no matter what our editor and operating system of choice may be. The OmniSharp project is sponsored by Microsoft. So as mentioned, we can install this extension from within Visual Studio Code. So to install the OmniSharp extension, let's click this button on the sidebar. And you can see that I've already installed the OmniSharp extension. You can locate the OmniSharp extension by typing OmniSharp in the relevant search text box, and then simply click the Install button. The other extension we should install is the NuGet Package Manager extension. This is so that we are able to install NuGet packages like, for example, Microsoft.Entity Framework Core. We'll look at how to install NuGet packages later on in this tutorial. So let's install the NuGet Package Manager extension. So now we have set up a foundation to start the creation of our C# application using Visual Studio Code. Let's temporarily close Visual Studio Code, and we'll use the .NET Core CLI, which stands for Command Line Interface, to create our solution. The .NET Core Command Line Interface CLI is a cross-platform toolchain for developing, building, running, and publishing .NET Core applications. The CLI was installed when we installed the .NET Core SDK. So let's go to our command prompt, and firstly, let's see what project templates are available to us through the use of the .NET Core CLI. So to do this, we can type this command, .NET new, and then press the Enter key. And a list of available project templates is presented to us. For example, Console Project Template, Web Project Template, MVC Project Template, gRPC Project Template, and SLN template. We are going to start by creating a solution file using the SLN template. A solution file is useful when creating more than one project as part of the same solution. Our C# application will contain two projects. One project based on the console application project template. This project will reference another project derived from the class library project template. So the first thing to do is choose a development root directory, i.e. a directory where you'd like to create your application. So let's type cd followed by the path of the relevant development root directory to make the development root directory our current directory. The path for my development root directory is c:\development/C# applications. Then let's create a solution root directory, which is where we'll create the relevant SLN or solution file. So to do this, let's type mkdir, then the directory name, which is employee app vs code, and press the enter key. Then type cd employee app vs code and press the enter key to make the employee app vs code directory the current directory. And let's type .NET new to have another look at the available project templates. And we can use the SLN short name to generate our application's SLN or solution file. So let's clear the screen using the CLS command. And to create our SLN file, let's type .NET new SLN and then press the enter key. And now to open our solution within Visual Studio Code, we can simply type code followed by a full stop and then press the enter key. And our solution is loaded into the Visual Studio Code editor. Great! Please note that we are able to access the .NET Core CLI from within Visual Studio Code. We can do this by navigating to the View heading menu item and then clicking the sub-menu item labeled Terminal. Note that you are also able to invoke Terminal by pressing the Control back to character shortcut key combination. For Windows, there is a convenient shell selector located inside the Terminal dropdown that lets you choose between several detected shells, including Command Prompt, PowerShell, PowerShell Core, Git Bash, and WSL Bash. So we are going to use PowerShell. And we can now access the .NET Core CLI commands using PowerShell and Terminal. So let's create a root directory for where our source code will reside. Note that we could also do this using the command prompt, but we are choosing to continue using Terminal within Visual Studio Code. So let's create a directory named src. To do this, let's type mkdir src and press the enter key. Then let's make the src directory our current directory by typing cd src and then pressing the enter key. Now let's create two directories within the src directory. Let's create a directory where code for our first project will reside. The first project we create will be based on the console application project template. So let's type mkdir employee app vs code.employee console app and then press the enter key. This directory is where we'll create the code for our front-end user interface related code. We'll create a project derived from the console application project template to create the infrastructure for this project. Let's type CLS to clear the screen. Let's create a directory for our second project, and this project will be a class library project where we'll create our business rules related code. We'll name this directory employee app vs code.employee component. So let's type mkdir employee app vs code.employee component and then press the enter key. So we are now ready to create our C# projects for our application. So to create the console application project, let's first type cd employee app vs code.employee console app to make the employee app vs code.employee console app directory our current directory. Let's use the .NET Core CLI to create a project based on the console application project template. To do this, let's type .NET new console and then of course press the enter key. And by default, the project name will inherit the current directory's name. So the relevant project file will be named employee app vs code.employee console app.csproj. So let's go back one directory so that the src directory is our current directory. We can do this by typing cd ... and then of course press the enter key. So let's clear the screen by typing CLS and then press the enter key. We now want to create the project based on the class library project template. So let's first make the employee app vs code.employee component directory our current directory. And then to create the class library project, let's type .NET new classlib and then of course press the enter key. So let's use Visual Studio Code's Explorer to see what files have been generated for our relevant projects. Great. Let's click on the program.cs file, and you can see that the main method, which is the entry point of our .NET Core application, has been created with a simple line of code that prints the text "Hello World" to the console screen. And you can see within our code editor that IntelliSense and code completion is available through the OmniSharp extension that we installed earlier. Great. Let's navigate to the directory that houses our class library project. And you can see that a default class has been generated for us named class1.cs. So the next step is to add the two projects that we have just created to our SLN or solution file. So our current directory is employee app vscode.employee component. We want to navigate two directories back to where our SLN file is stored. So to do this, let's type cd ... and then press the Enter key. And then let's repeat this to move another directory back. So let's type cd ... and press the Enter key. The employee app VS Code directory is now our current directory where our SLN or solution file resides. Let's first add the console application project to our SLN file. To do this, let's type .NET SLN add and then the path of where the console application's .csproj file resides. So let's type src \employee app vs code.employee console app \employee app vs code.employee console app.csproj and then press the Enter key. Great, so we can now see that the output status is telling us that this command has been executed successfully. So let's type the same basic command, but this time to add the class library project to the SLN or solution file. Let's first type CLS to clear the screen, and type .NET SLN add and then the path of the project file for our class library project. So let's type src \employee app vs code.employee component \employee app vs code.employee component.csproj. And then let's press the Enter key. And the output status is telling us that this command has been executed successfully. Great. Let's type CLS to clear the screen. So we now want to create a reference to the class library project from our console application project. To do this, let's make the directory containing the employee app vs code.employee console app.csproj file our current directory. To do this, we type cd src \employee app vs code.employee console app and then press the Enter key. And then let's invoke the appropriate .NET Core CLI command to create a reference to our class library project from our console application project. We want our console application project to reference our class library project. So to do this, let's type .NET add reference and then the relative path to our class library project file. So we type \employee app vs code.employee component \employee app vs code.employee component.csproj, followed by pressing the Enter key. And the output status is telling us that this command has been executed successfully. Great. And if we take a look at the employee app vs code.employee console app.csproj file, from within Visual Studio Code, we can see within the XML, within the employee app vs code.employee console app.csproj file, that a reference to the employee app vs code.employee component.csproj file has been included. Excellent. Okay, so let's create the code for our application. We're going to keep the code very basic. Let's first create the code for the class library project. This class library project will only contain one class, which will denote the structure for an employee record. So let's first delete the class named class1.cs, which was generated for us when we created the class library project. And let's create a new class from within Visual Studio Code like this. Let's name it employee.cs. It is very important when creating the class file within Visual Studio Code like this to include the .cs file extension. So within the employee.cs file, let's create an appropriate namespace based on the class library project's project name. Let's create a namespace named employee app VS Code.employee component. Let's use the class keyword to create a class, and let's make this class public. Let's name this class appropriately. Let's name this class employee. Within the employee class, we only want to create 4 auto-implemented properties: ID as integer, first name as string, last name as string, and gender as char. So let's navigate within Visual Studio Code's Explorer to the console application, and let's write code within the main method in the program.cs class file. The main method is the entry point for the application. So firstly, let's create a using directive to the employee app VS Code.employee component namespace. We are able to do this because earlier we successfully added a reference to the employee app VS Code.employee component .cs proj file from this console application project through the use of an appropriate .NET Core CLI command. We are going to use a generic list to store our employee objects, so let's include a using directive at the top of our code to the built-in namespace named system.collection.generic, and then let's follow this with a semicolon. Within the main method, let's instantiate a generic list named employees that is strongly typed as the employee user-defined type. So this list can only store objects derived from the employee user-defined type. And let's make up some employee data and encapsulate this data within 3 objects derived from the employee class. Each object denotes an employee record. If you don't wish to type out this code, please feel free to copy this code from the GitHub webpage at this location and appropriately paste it into your code editors. A link to this webpage has been included below in the description. Let's write code to implement a for each loop to traverse the employee objects we have added to the employees list and write each of the employee property values to the console screen. And that is basically our little application written. So next we want to run and debug our code. So when we double-click on the program.cs file, we should have been prompted with a dialog box prompting us to add required build and debug assets needed to build and debug our C# application from within Visual Studio Code. So if the appropriate dialog box appears to you in the bottom right-hand corner of your screen, click the Yes button and the appropriate assets for building and debugging a C# application within Visual Studio Code will be added for you. If, however, you have not been prompted to do this, and you have not yet added these required assets, we are able to manually trigger this by using Visual Studio Code's command palette. Visual Studio Code's command palette can be used to access all available commands based on your current context. A keyboard shortcut to invoke command palette is Ctrl-Shift-P. So to load the command palette, we can also navigate to the View heading menu and then click the submenu item marked Command Palette. So we want to restart OmniSharp so that we can load the required assets. So to do this, we can type OmniSharp :restart OmniSharp within the relevant text box, like this. And now we are prompted with the appropriate dialog box which can be seen in the bottom right-hand corner of my screen. The text on the dialog box states, "Required assets to build and debug are missing from employee app VS Code. Add them?" So, we are being prompted to add the relevant build and debug assets. So let's click the Yes button. And you can see that within the employee VS Code app directory, a new folder has been created named .vs Code. And within the .vs Code folder, two JSON files have been created, namely launch.json and task.json. Visual Studio Code keeps debugging configuration information in the file named launch.json. The task.json file allows the developer to customize certain tasks to be run within Visual Studio Code, rather than how these tasks might usually be executed, for example, through a command line interface. An example of an automated task for a C# application is the use of MSBuild to compile a C# application. The Microsoft Build engine is a platform for building applications. This engine, which is also known as MSBuild, provides an XML schema for a project file that controls how the build platform processes the build's software. So if you look at any of the .csproj files, these are written in XML format and allow developers to customize these files. A developer is able to extend the .csproj files from within Visual Studio Code, Visual Studio, or by using an XML editor. MSBuild is detached from any one specific code editor or IDE, and msbuild.exe can be invoked on a project or solution file that can orchestrate and build products in environments where Visual Studio isn't installed. So MSBuild can be used to build our C# applications created through Visual Studio Code. So now that we have a valid launch.json file and a valid task.json file, we can navigate to Visual Studio Code's built-in debugging facility by clicking this Visual Studio Code sidebar button. And to run and debug our code, we can now simply click the play button like this. Great, and we can see our output in the debug console window. And notice we can utilize the debug facilities to track local variables, and we can also add variables so that we can watch their values change as we step through our code. We are able to include breakpoints within our code, so let's insert a breakpoint here. And let's run the code. And you can see our code has stopped executing at our breakpoint. And let's add the employees variable to the watch list. And let's step through the code. Great. And finally, once we have run our code all the way through, we can see our employee records displayed to the console screen. Excellent. So an important aspect of creating .NET Core applications is being able to download and install NuGet packages. This is very easy through Visual Studio, but how can we do this through Visual Studio Code? Say, for example, we wish to download the Microsoft.Entity Core .SQLite NuGet package, so that if data for our employee records were to be stored within a SQLite database, we could include SQLite database handling functionality using the APIs provided in the Microsoft.Entity Core .SQLite NuGet package. How could we do this? So, firstly, we can navigate to this URL, and we are doing this so that we can get the full name of the NuGet package we wish to install for our application. So in the relevant web page's search text box, let's type text that is close to the name of the NuGet package we wish to download and install through Visual Studio Code. We can then look through the search results and identify the name of the NuGet package of interest to us. So there it is, Microsoft.Entity Core .SQLite. So let's click on this link. Let's then copy the name of the relevant NuGet package to our clipboards. And then let's invoke the command palette from within Visual Studio Code by clicking the View menu item and then the Command Palette submenu item. Then within the relevant text box, let's type NuGet Then let's select NuGet Package Manager : add package item. And then within the next prompt that contains the prompt text, enter the name or search for a NuGet package. Let's paste the name of the relevant NuGet package, namely Microsoft.entity-framework-core.sqlite, and we are prompted to choose which version of the NuGet package we wish to install. Let's select version 3.1.4 from the drop-down list. And we are then prompted with a drop-down list containing all the projects available in our solution. The relevant prompt text states, to which project file do you wish to add this dependency? Let's select the project named employee app vscode.employee component. So a dialog box in the bottom right-hand corner has just appeared that contains the following prompt text. There are unresolved dependencies. Please execute the restore command to continue. So let's click the restore button. So now let's see if we are able to add a using directive to the Microsoft.entity-framework-core.sqlite namespace. Great! And now we are able to leverage the object relational mapping functionality available in the Microsoft.entity-framework-core.sqlite NuGet package from within Visual Studio Code. We are not going to add database handling functionality in this tutorial because this part of the tutorial is only intended as a broad overview for adding NuGet packages to our applications through Visual Studio Code, and not for handling data using the relevant object relational mapping API. I'd like to quickly demonstrate that we are able to switch to the Visual Studio IDE if we so choose. So to do this, we can simply load Visual Studio, locate the relevant SLN file, and double-click the file. And as you can see, we can immediately debug and run our application through Visual Studio. Great! I also want to give you an idea of how an ASP.NET Core MVC project could be developed using Visual Studio Code. Please note we are not going to go into detail regarding MVC applications. This is just to provide a basic overview of how you can create and test an MVC web application using Visual Studio Code. Right, so using the command prompt, let's navigate to our root development directory. And let's create the root directory for our MVC application. Let's create a directory named MVC app VS Code. Let's make this directory our current directory. And to create the MVC project, we can type .NET new MVC followed by pressing the Enter key. To load our newly created ASP.NET Core MVC project within Visual Studio Code, we can simply type code and then followed by a dot and then followed by pressing the Enter key. And our MVC project is loaded within Visual Studio Code. If we double-click on the program.cs class, we are prompted by a dialog box which appears at the bottom right-hand corner of our screens to add the relevant build and debug assets. Let's click the Yes button. Remember, if this dialog box does not appear when you have double-clicked the program.cs file, you can use the command palette and run omnisharp : restart omnisharp to trigger the appearance of the relevant dialog box. And we should now be able to run our application through the debug facility provided within Visual Studio Code. So let's press the play button to run the application. If you look at the debug console window, we have our web server listening at this location, https://localhost:, and the port number is 5001. And the web server is also listening at this URL, http://localhost, and the port number is 5000. And because I don't want to get into SSL certificates in this tutorial, I'm going to go into the code and bypass the automatic redirect to the HTTPS location by commenting out the app.use HTTPS redirection line of code that can be found within the configure method of the startup.cs file. This certainly isn't recommended for when you are creating a professional web application, as HTTPS is a very important part of web-related security. But in the interests of demonstrating the basics of creating an MVC application in Visual Studio Code, I have chosen to bypass HTTPS and we'll navigate to the HTTP location. So let's run the code again. Let's navigate to the http://localhost location, and the port number is 5000, so we type :5000 within our browsers, and we can see that the basis for an ASP.NET Core MVC project has been generated, and we are now able to customize this project and test it from within Visual Studio Code. Excellent. To summarize, we first ensured that the latest version of the .NET Core SDK was installed on our development computers, and then we made sure that the latest version of Visual Studio Code was also installed on our development computers. Through Visual Studio Code, we installed 2 extensions from a central location known as the Marketplace. The first extension is named OmniSharp, and the second extension is named NuGet Package Manager. We then created a solution file or SLN file through the .NET Core CLI by running the following command, .NET new SLN. Then we loaded the solution within Visual Studio Code by typing code space dot at the command prompt. We added 2 projects through the use of the relevant .NET Core CLI commands to our solution. One project derived from the console application project template, and the other project derived from the class library project template. Through the use of a .NET Core CLI command, we added a reference to the class library project from the console application project. We then created the code for a basic application using the Visual Studio Code editor. We ensured that the relevant debug and build assets had been added, which resulted in 2 necessary JSON files being created. The names of the JSON files are launch.json and task.json. We then ran the application through the debug facility available within Visual Studio Code. We then installed a NuGet package through the command palette facility, which is available from within Visual Studio Code. Specifically, we installed the Microsoft.EntityFramework Core.SQLite NuGet package. We then ran the project that we created through Visual Studio Code from within Visual Studio to prove that we could now use either the Visual Studio Code editor or the Visual Studio IDE to develop and test our application. Lastly, we created the basis for an ASP.NET Core MVC project and loaded the project within Visual Studio Code. We then ran the project through Visual Studio Code. This gave us an idea of how we could develop, run, test, and debug an ASP.NET Core MVC application through Visual Studio Code. And to conclude this tutorial, I'd just like to say that Visual Studio Code is a powerful, cross-platform code editor. It is not as straightforward as using the Visual Studio IDE to develop C# applications, and definitely requires a lot of getting used to, especially if you are used to developing C# applications using the Visual Studio IDE. Using Visual Studio Code does force us to understand some of the underlying parts associated with developing, building, testing, and debugging our C# code. It is a lightweight cross-platform code editor and can serve as a useful tool for building a variety of different types of projects using the C# programming language. I hope you've enjoyed this step-by-step guide to working with C# using Visual Studio Code. For more content like this and much more, please consider subscribing and please ring the bell so that you can be notified of future releases from this channel. If you feel that you have gained value from viewing this tutorial, please hit the like button. It will be greatly appreciated. Please feel free to share this tutorial with anyone you feel may benefit from its content. All links referenced in this video are available below in the description. Please feel free to provide feedback about the tutorial in the comments section. The code created in this tutorial can be downloaded from GitHub. A link to the relevant GitHub repository has been included below in the description. Thank you, and take care.